Now we're going to start on the electrolysis of solutions, and we had a previous vlog that dealt with the fact that with solutions you have water present. And when you have water present, Dr. Bowen,
it complicates matters.
And how does it complicate matters?
Because the water ionizes, so you've got hydrogen ions, that's H+, and hydroxide ions, OH-, that are also present in the electrolyte, and they have to be considered when you think about what's going to happen at the electrode.
So that means you've got the positive and negative ions from the ionic compound, as well as the positive ions from the water and the negative ions from the water.
Absolutely
Is
right.
that correct?
Yeah, because all the action happens at the electrode.
So that means you need to consider the hydrogen ions from the water as well as the hydroxide, which means that you've got two ions going to each electrode. Now that does create problems because only one of those ions at the electrode will either gain or lose electrons.
And that's got a special term called being discharged. So the ion that is discharged is the one that gains or loses electrons. The other ion that didn't win the race stays in solution.
Perfect. So it's that order of discharge.
Yeah.
Now, there are certain rules for this order of discharge, and it's not too complicated. It's very straightforward. So the rules for the cathode are, Dr. Bourne?
Right, so the cathode is the negative electrode, so it's going to attract positive ions. So you're going to have your hydrogen ion and one other, presumably. So when they get there, if you look here, the one that would be discharged first would be the least reactive of everything. So silver, Ag+, is less reactive than copper, and that's less reactive than the hydrogen ion. So the least reactive metal would be discharged before hydrogen. If you've got a more reactive metal in the mix, such as sodium, the hydrogen would be discharged and the sodium would stay in solution.
Well, I think actually I've sort of sussed that out. So, for example, if you had two positive ions, Na plus H plus, then that means, because hydrogen is the least reactive between these two positive ions, that's going to be discharged. Is that correct, Dr.
Yes, absolutely.
Excellent.
Right.
And another example that I prepared earlier, I wouldn't want to disappoint you. If you've got a copper 2+ ion, a hydrogen ion, that's the least reactive ion, so that's the one that's going to be preferentially discharged, i.e. that's the one that's going to pick up the electrons.
Yes.
Oh, so that's very straightforward.
Very straightforward.
Now we're moving on to the rule for the anode, Dr. Bourne.
Right, so the anode is the positive electrode, so it attracts the negative ion. So from the water, we're going to have the hydroxide ion, and we're going to have another ion. Now, commonly you might encounter the halide ions. Those are the ions from the halogens, the group 7, chloride, bromide, iodide. And of those, the one you're going to encounter most often is Cl-, the chloride ion. Now, if chloride ions are present, they will be discharged before the hydroxide. After that, the other one you might come across as a sulfate ion, and you don't need to worry about that. That will not be discharged. The hydroxide ion would get discharged.
In preference. So I think if I have actually understood that rule...
I hope you've got one of your boards.
I've got 3 of them, actually.
So, should we go through that? Yes.
We have a sulfate ion hydroxide. So from that rule, it means hydroxide is discharged. So that's the one that's going to lose electrons, so it'll be preferentially discharged.
Yes.
Excellent. I think I'm getting the idea now.
Good.
And then we have another one, which is Cl-, chloride and hydroxide. So from that rule, chloride is a halide, so it will be discharged, i.e. it will actually lose its electrons in preference to that.
Yes. And finally?
And the final one, last but not least,
iodide.
Iodide and hydroxide. Now that's a halide, so that's going to be discharged in preference to hydroxide.
Right, so in summary, if you've got a halide that's chloride, bromide or iodide, they will be discharged. After that, it's the OH minus, the hydroxide ion.
So we're going to use these rules in the next vlogs where we're going to be electrolysing specific solutions. Well, I still feel electrified. I don't know about you, Dr. Bond.